In this lesson, we'll be looking at piecewise defined functions. Our objectives will be to evaluate a piecewise defined function and then to graph a piecewise defined function. Let's start with evaluating a piecewise defined function. First of all, let me give you one, and let's talk a little bit about what this means. Notice that it starts off with f of x is equal to, which tells us it is a function. But then what I want you to notice is what you have are basically three different pieces, hence the name piecewise defined. I want you to notice that when x is between -4 and 2, the function is defined as x minus 1. When x is between 2 and 4 inclusive, meaning it has the endpoints on that, then the function is defined as a -2x. And when x is between 4 and 8, including the 8, then the function is defined as 2x minus 10. So what that means for us is this. If we want to evaluate this function for f of -3, the first thing we've got to do is to identify which one of these pieces that -3 falls into. So let's look and see. Is -3 between -4 and 2? Well, the answer to that is yes. So what we will do is we will take our -3 and we will use this part of the function to evaluate it. So we'll plug our -3 in for x. We'll have -3 minus 1, and we'll get an answer of -4. Let's evaluate again. This time we want to evaluate f of 7. Once again, the first thing I have to do is figure out which one of these pieces that this number falls into. Well, is 7 between -4 and 2? No, it's not. Is 7 between 2 and 4? No, it's not. Is 7 between 4 and 8? And the answer to that is yes, it is. So we will use this part of the function to evaluate this time. So we'll plug our 7 in. So we'll have 2 times 7 minus 10. And when we evaluate, we'll get 4. Let's do another piece. What about f of 0? Well, once again, we need to determine which one of these intervals it falls in. Well, is 0 between -4 and 2? Yes, it is. So this is the one we'll use right here again. So we'll plug our 0 in. We'll get 0 minus 1 for an answer of -1. Let's do one more. What about f of 3? Well, this time we need to determine where the 3 falls. Is it in the first interval, the second interval, or the third interval? Well, it turns out this time that it falls in this interval, so we'll need to use this part of the function. So we'll plug our 3 in, and we'll have -2 times 3. We'll get a final answer of -6. Now we've done those 4 examples, but I do want to ask you about one more thing. What if I had given you f of 2 and I ask you to evaluate it? This time I need you to look at which one of these intervals does 2 fall into. Well, I can eliminate the bottom one, it's not there. But is it in this one or this one? It's important that you know the difference between these two. Notice that on this interval, the 2 is included. It has the equal sign. There is no equal here. So the 2 falls into this interval, and so to evaluate that, you would say -2 times 2 and get a final answer of -4. Let me ask you one more while we're thinking along those lines. What about f of 4 this time? Well, if I wanted to find f of 4, once again, I need to know which of those intervals it falls into. Once again, right there's the equal, so that's the interval you must use. So we would be taking our -2, multiplying it times 4, and get a -8. So there are 2 parts to evaluating a piecewise defined function. You must choose which interval the number you're evaluating falls in, And once you've made that decision, then actually evaluate using that part of the function. Now let's look at how we can graph a piecewise defined function. Let's take the same function, but this time we want to draw a graph. Well, what we'll do to begin with is we will graph the line x minus 1. Now you can do this on your calculator, or you can do this manually, whichever way you want to go about graphing. But I want you to notice that what we're going to do is we're going to graph the line x minus 1, and then what we're going to do is we're going to cut it off. The line x minus 1, if you had graphed the whole thing, would have extended further this way and further this way. But what we're going to do is cut that line off. And because we have an equal right here, we're going to put a solid circle here. And because we have a less than without an equal here, you'll notice we have an open circle. So we graph that first piece totally, and then we move on. Next, we want to graph the line y is equal to a negative 2x. Remember, its slope is negative 2 and its y-intercept is 0. So you graph that entire line. Y-intercept is right there. Slope is negative 2, which would be down 2 to the right 1. And your line would look like this. But you only want the part of it that is between 2, right here, and 4, right here. On both ends this time you'll need a solid circle. So let me clean that up for you and put that in. Once again, we have a third line that we need to graph, 2x minus 10. When you graph this line and then cut it off at 4 and 8, because the 4 is less than there without an equal, notice we have the hollow circle here, and then with the 8, the equal to is there, so we have a solid circle. So there's a graph of your piecewise function. Let me ask you this question. What would happen if I changed the function just slightly and I added this line right here? Well, what that would do to that first line, that blue line that we drew, is it would make this be a solid circle. My question is, would that be a problem? And the answer is it would be a huge problem, because what that would mean is now I could draw a vertical line that would touch the function in more than one place. It would hit, if I had drawn it correctly there and it had hit both of those dots, one vertical line would hit the function in two different places, which means it would not even be a function. So if I had that situation, then our piecewise function wouldn't even be a function. So as long as one of the circles is open, it's okay that the other one is closed. Notice I have the same situation over here. I could make this one be open and close this one, but I cannot have them both closed, or else I would have a vertical line test that would fail right there, and it would not even be a function. Now I know these look a little scary when you first start seeing them for the first time, but a piecewise function is really not that difficult. It's just a matter of deciding which interval your number you're evaluating falls into, and it's also a matter of graphing and then erasing the part of the graph you do not need. Let me know how your homework goes, and I'll talk to you soon. Bye-bye.